Our current data binding system handles our player, coins, and laser switches, but it does the players in a slightly different way. And if you take a look at our coin and laser switch code, they're almost essentially duplicates of each other. They do about the same thing. They find an object by name and then match up that data. If the data exists, it binds up to that data, and if not, then it creates a new one. And if we want to create new items that we want to bind to, for instance, items that we can pick up like our keys and blasters or anything else that we want to bind to, we have to copy and paste this code and make little modifications to it. And I'd like to eliminate that and dive into a slightly more advanced topic of generics. Now, you've used generics before. You can use generics right here. Find objects of type is searching for things using the generic syntax and finding all of the laser switches or the coins, but we're going to use generics in a slightly different way. Instead of just using a method that implements or takes advantage of generics like find objects of type, we're going to create our own bind method that takes some generics and allows us to generically bind up one object to its data, no matter what type of object and data we have, as long as they follow the same contract or interface. And to start, we're going to create some interfaces, and then we'll do our binding. Let's start with the coin class. Let's go take a look at our coin. Our coin has a bind method, and it binds to coin datas. So we're going to add an interface here that tells our system, or our persistent system, that our coins bind to a coin data. We'll do that with an interface, and let's call it iBind. We're going to just add this at the end of coin, and then we'll create the interface right afterwards. So say iBind, and we're going to give, not iBindable. iBindable is part of the UI elements that auto-completed. So we're going to do iBind and make our own. It's part of the UI elements package. So we're going to do our own one called iBind, and we're going to bind to coin data. We're going to give it the type of coin data. And we don't have an interface called iBind yet, so we're going to need to either generate it or go type it down below. I'm going to create it right here in this file and then maybe move it over to our game data class later, so our game data file. So we've got an internal interface named bind. Let's make this public real quick, and it binds to a type of T. Inside of that interface, we just want to have a single method called bind to the data. So now we've got this interface here. Absolutely nothing has changed though. Let's go take a look at our game manager. So in our game manager, now that we have our coin as an iBindable, perhaps we can implement a way to bind it up. Let's go take a look at our bind coins method. So here, remember, we loop through all of our coins, and then we find the coin data by name, matching it to our coin object, and then we bind it up or add it to our coin data. If it doesn't exist, then bind it to the actual object. So let's add a method here that allows us to bind things slightly more generically, that allows us to bind things that are iBindable to a type. So we'll do void bind, and we're going to take a type and then the data type. And we're going to call this method bind, and then, whoops. And I already called the method bind. We're going to give it a parameter, and the parameter is going to be a list of D, and we'll call this datas. So this will be either all of our coin datas or all of our item datas or laser switch datas or whatever other type that we want to pass in, instead of passing in the level data, because if we passed in the level data, we'd have to figure out which object to get. So we'll take our list or our bind method here, and we're going to do the same thing that we do in bind coins. First, we're going to find all of the objects that match the type. So I'll say var instances equals find objects of type. Let's see, find objects of type. There we go. And then we're going to give it the type T. It's going to find all of the objects of type T. But now you see we've got an error here because it says the type T can't be used as a parameter in the generic find objects of type because there's no conversion from type T to object. So let's go back to let's add a restriction here that says that T must be a game object or must be a mono behavior. So we'll say where T mono behavior. That'll get rid of the error here because now it knows that whatever type we specify here will be a mono behavior that has to be able to be gettable with find objects of type. So now that we've got all of the instances, let's loop through them. So we'll say for each instance in instances, and then we'll find the data for that instance, just like we're doing down here in bind coins. We can pretty much follow along, just rewriting the method a bit more generically. We'll say var data equals datas, because remember we're going to pass that in, dot first or default, and here we're going to want to match on the name, t.name is equal to our instance.name. Now we've got another error here because t.name does not exist. Remember, our coin data has a name on it, so we're able to find it down below, and our laser switch data has a name on it, but our data object here, this D, does not have a name on it. So we're going to need to be more specific and say that our data type must also have a name. To do that, we're going to add in another statement here. We'll say where D colon I named. And we're going to need to generate an interface for iNamed that just has a name property on it so we can get that name and read it. So let's go generate an interface now. We'll generate this down here at the bottom of our file, and we'll add in a, scroll down here a little bit, string name, and we'll add a getter and a setter because we're probably going to want to set that later. All right, so we've got our iNamed interface, and now our data line works. We can now get the correct data from our list of datas. If we don't get a data object back, just like on 94, we need to create a new one. So we'll say if data equals null, then data equals new, and here we're going to give it a new D, which is our data type, because it could be a coin data, it could be a level data, or something else. We'll add in our parentheses there, and then our, let's put the braces so that we can assign the name. So say name equals instance dot name. Now we're going to have an error here, and again, this error is because we're not being specific about what type of data it is or what the data type has. And here it says that we cannot create a new instance of variable D because it doesn't have a new constraint. And what that means is that we haven't told this method that D is an object that can actually be newed up. You know, some objects you can't do a new instance of, most of them you can, but in this case we just need to be very specific and say, hey, this thing can be new by adding a new right at the end. So we add comma after the iNamed and new, which just means that this part here, the data object, implements iNamed and can be instantiated. So now that we've got a new data, we'll just say datas.add, and we'll add in that data, and then close out the braces, and then finally call instance.bind, and we're going to bind to that data. Now we don't have a bind method on our instance, so why is that? Well, it's because our T right here doesn't specify that it's also iBindable. So we need to add that as well. We've got our mono behavior. We're going to do a comma, iBind, and I said iBindable, but I meant iBind, and we're going to bind to D. So now we've got this complicated looking method, but it's really just binding up types of T to data objects of D, and we pass in a list of data objects of D. D is our data type, T is our object instance type. So now that we've got that working, we've got that completed, let's go hook it up instead of calling bind coins. So we're going to go up to our part where we call bind coins. Let's see if we can find it. Bind coins right here. And we'll call bind. And we're going to bind coin to coin data. And then we'll pass in our level data dot coin datas. Whoops, let's see if I can spell it right. Now I'm going to comment out the bind coins method, and we're going to fix the last error here, which says that the coin data cannot be used as a parameter D because the generic type, because there's no implicit conversion from coin data to iNamed. And that's because if we go over to our coin data, we added that iNamed interface, but we haven't actually implemented it. So we're going to add in an iNamed here. And then that also means that we're going to need to make our public string here be a property instead of a field. So we're going to add a get and a set. We'll save and do a build. Now, if we just jump in and play and grab our coins, you'll see that there's actually an issue with the way that it persists. I can go grab and collect all these coins, but if I save and then reload, we're going to get multiple new elements and our coins aren't binding up properly. And the reason for this is actually very simple. If you look at these element names, notice something that's missing, or these, I think I might have kind of hinted it there. But if you look at these, notice that the name is here on our laser switches, not on our coin datas. The reason for this is simple. When we converted our property here, the name to be a property, it stopped getting serialized by Unity. Since we're using Unity's serialization system, we need it to be serialized by Unity for this stuff to work. Otherwise, we're going to have to swap out our save system, which is another viable option. But an easy solution for this, so we can also see it in the inspector, is right at the beginning of our property here, and you can do this on any property that's got a getter and a setter. We're going to add a field : serialize field. I spelled that wrong, but if I can fix my typing, There we go. What this will actually do is take the backing field, the hidden backing field for our name property that's automatically created whenever you create a property. It creates a hidden name property that's going to be get and set when you call this getter and setter. It kind of auto generates that code. And this is saying, hey, for that field that you're auto generating, serialize it. That's all we need to do. Let's go back into Unity now, press play. And now when we look at that player data, notice that we've got all of the coin names. Those are working. I can run over here, collect things, save them all, reload. I don't have duplicate data, and my state is correct. Now before we commit, let's do a quick diff on our files. Just make sure we've got everything right. So our coin now just has that iBind interface in it. We'll move that around later. And then we've got our game manager, which has the bind method and is no longer calling bind coins, but calls the generic one. And then we've also got our coin, which has, or our coin data, which is now iNamed, and we have that iNamed interface. All right, so with that, I think we can commit that we've added generic data binding and check it in.